So what I have here on the board are two numbers that, as you can probably tell, are really hard to work with and to name. So the first one is the number of molecules in a drop of water. So the number of water molecules. So you grab a really small drop of water, and this is the number of water molecules that you're going to find. So this number is a 1, a 6, a 7, and who knows how many zeros. So it's bigger than a billion, it's bigger than a trillion, it doesn't even have a name probably. It just has that many zeros. And the second one is the mass of an electron in kilograms. So if you can remember from science class, an atom is made of electrons, protons, and neutrons. And electrons are the smallest ones of these particles. So if you wanted to express their mass in kilograms, you would get 0.000, who knows how many zeros, and then a 9, a 1, a 0, and a 9 kilograms. So the number up here is really, really big. It's a huge number. And the number down here is a very, very tiny number. And the scientists started working with these kinds of numbers. They realized that they needed to find a way to make it more compact and easier to make calculations and to name these numbers without having to write 30 or 40 or 60 zeros on a piece of paper. So these numbers are in what is called standard notation, which is the way in which you guys are used to writing numbers every day in your lives. But the notation that they invented, or the way of writing numbers that they invented, is called scientific notation. So the way that you write a number in scientific notation is you follow these steps. So first you write in this little square that I'm going to draw, you write a number from 1 to 9. A single number from 1 to 9. Then you put a decimal point. And then here you write a number which can be as big as you want. It can be 5, 6, 8, 32, whichever number you want that has the rest of the important numbers that you want to express. And then you write times 10 to the, and up here you write an exponent. This exponent can be a negative number or a positive number or even 0. It can be any whole number that you require. Okay, so maybe this makes no sense, so I'm going to start with a couple of examples. So an example of a number in scientific notation can be, let's say for the first number, any number between 1 and 9, let's say 5, then a decimal point, and any number with any number of numbers. So let's say 13. That's a number. And then you put times 10 to the, and in the exponent, a number. So let's say again 5. This is a number in scientific notation, but what does it mean? So what it means is that this 10 to the power of 5 means how many times you're going to move this decimal point to make the number bigger or smaller. So in this case, what we do to pass this number to standard notation is we first write these numbers that we have here, but without the decimal point. So in this case, it's a 5, a 1, and a 3, without the decimal point. And then we move the decimal point that used to be here, we move it 5 places to the right. So it was here, and we move it 1, 2, 3, 4, and 5 places to the right. And to complete the number, we fill it up with zeros. So we put 1 0 in every space that we had left, and that is our number. So to write it a little bit prettier, this is 513,000, 513,000. So 5.13 times 10 to the 5 is a very big number, 513,000. That's one example. Now let's see what happens if the exponent is negative. So I'll use these same numbers, just for the example, 5.13, and then here 13, and times 10 to the, but instead of positive 5, we'll have negative 5. So what that means is that we'll have a really small number. When the exponent is negative, the number is small. How small? Well, we do the same thing, but instead of moving the decimal point to the right, we're going to move it to the left. So what we do is we write the same 5, 1, and 3, but maybe on this side so that we have space to put zeros on the other side. So the decimal point used to be here, and we want to move it 5 places to the left. So that's 1, 2, 3, 4, and 5. So our decimal point is now going to go right here, and we fill it up with zeros like we did before. So now the number is 0.0000513. So usually when we have a point, we put a 0 on the left just for notation. So we get 0.0000513. So 5.13 times 10 to the 5 was 513,000, but 5.13 times 10 to the negative 5 was 0.0000513. Yeah, so those are the two examples. So you can notice that numbers with a positive exponent are bigger than 1, and they have zeros on the right, so they make big numbers. And numbers with negative exponents are less than 1. So they're always going to start with 0 point something. If you see 0 point something, the exponent is going to be negative. If you don't, if you see a number that's bigger than 1, the exponent is going to be positive. So now that we learned how to do that, to pass from scientific notation to standard notation, we can go back to our original two huge numbers and try to express them in scientific notation to see if they do become more usable. So the first one was a 1, a 6, a 7, and a lot of zeros. So the way that we start passing it to scientific notation is to take these numbers that are important, that give us information, and put them here. So one number, we can only choose one number to go here on the left of the point. So that number is going to be our 1. So 1 point. And then the rest of the numbers, the rest of the important numbers, we put them to the right of the decimal point. So that is the 6 and the 7. So 1.67. Now we put the times 10 to the, and in order to find out what our exponent is going to be, we need to count the zeros. That's the only way that we can figure out how big the number is. So we're going to count the zeros, and we know that the exponent is going to be positive because this number is much bigger than 1, and it doesn't start with 0 point something. So it's going to be positive, but what number specifically? So this number has its decimal point at the end because it has no decimals. So we place it there, and we count how many times we need to move it to the left to get to 1.67. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21 to get to 1.67. So that's going to be our exponent. 1.67 times 10 to the 21 is the number of water molecules in a drop of water written in scientific notation. You can see that it becomes much more compact and it's easier to use. And as we'll see later, it's also easier to do calculations with it. Okay, and now the second one. The second one also has a lot of zeros, and the important numbers, the numbers that we care about, are here at the end. So we have a 9, a 1, a 0, and a 9. Those are the numbers that are different from 0, this one is important because it's between two numbers. So we can only choose one number to be here at the beginning, so that will be our 9. Then we place the decimal point, and then we put the rest of the numbers. So in this case, it's a 1, a 0, and a 9. 9.109. And now we do the times 10 to the. So now the exponent is going to be negative because this number is less than 1, and it starts with 0 point something. So we know that it has to be a negative exponent. So we put the negative, and now to see negative what, we count the number of times that we need to move the decimal point. So we have it right here, and we want to move it to the 9.1. So we don't want to move it to the end, we want to move it to where we put it, between the 9 and the 1. So we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. So the mass of an electron is written in scientific notation 9.109 times 10 to the negative 31 kilograms. So again, this is a lot shorter, a lot easier to use than this huge number with lots of zeros. It's easier to put in the calculator, and in general, it makes a lot more sense to write it like that than to write it like this. So we learned how to pass from scientific notation to standard notation, and now from standard notation to scientific notation. An extra tip is that when you get a number in the calculator that looks something like that, so maybe you've made a calculation sometimes and you get a number that is maybe 2e6. So that e that you maybe didn't know what it meant before is exactly the same thing as times 10 to the something. And that something is the 6. So this is a calculator's way of saying 2 times 10 to the 6. Yeah, if it said maybe 5.13 e minus 5, that is the short way for the calculator to write exactly this number, 0.0000513. So that's just a bit of help in case you get that weird number in the calculator. But that's the introduction to scientific notation.